Hello and welcome back. In this lecture I want to provide a demonstration of our challenge for pointer arithmetic and using the constant modifier. Let's bring up code blocks. I'm going to create a new project. We're going to name this one pointer arithmetic example. Okay, so what we're going to do here is we're going to actually determine the length of a string by using pointer arithmetic. So the first thing I want to do is I want to create my function declaration. This is going to return the length of the string, so it's going to have int as the return type. I'm going to call it string length, and this is just going to take a pointer, but it's going to be a constant pointer. We don't want to change the value of what's pointing to. So that means we would use the constant as the first keyword, and then we would specify the type, which is a character, and we would say star, and we can name it whatever we want, string. Now again, just to reiterate, if we would have put the constant here instead, this would say that the address of the pointer's value cannot change. But again, it's kind of redundant and it doesn't really need to be done because we're doing pass by value, pass by copy. So you have a copy of the address anyway, so it doesn't matter if you change it in there. But it is important to change what you're pointing to. If you do not want the value of what you're pointing to change, you definitely want to do constant here. And that's important. So now all we have to do is we're going to create our main. All we're going to do in our main is we're going to call string length, a string length function with different strings. So let's print out, and remember it returns an integer, so we can say %d, and we're just going to print out the length of a couple strings that we pass. So we're going to call string length, and we're just going to pass in some constant strings. So we can just put things in double quotes here. We don't even have to create pointers. You could create a pointer and assign it and then pass it in, but you just have to make sure it's a constant. But since it's easier and less code, we can just say string length test. Again, that's a constant literal string, right? We'll test it with some more. We'll say, we'll put a space after it. Let's actually, instead, let's add some line feeds. Here we'll call string length, and actually let's call it with the empty string. Make sure it returns 0. And then our third one, we'll say string length, and we'll just say JSON. Now incidentally, when you create these and pass these string length things, they automatically get the null terminator added to them, right? We learned that when we declare pointers. That's one of the advantages. If you're going to create a pointer and it's going to be a literal, you don't want to specify the size. You know, you'd want to do something like character, if it's an array, because an array is a pointer. But if we wouldn't want to specify the size, we could say character p, and then inside here we could just say JSON, right? Remember that lesson where if we don't specify the size for character arrays, it will automatically add a null terminator and create the size for you. That way you don't make any mistakes. If you put the size inside the array, you might not have enough of the null terminator. It's the same thing when we pass the literal to the string length. The null terminator gets added to the end of it. So we could have created these variables, initially and done something like this and then passed in each one. But I didn't want to waste time creating variables. So I'm just going to do that. Now what's really important for this code is the function. So we're going to create our string length. Remember again, it returns an integer. And it's going to be a constant, so we can just say constant char star string. And you also notice that the function declaration variable name doesn't have to match. I could put this as strings, and that's fine as well. Now, inside this function, we have to create a local pointer because the local pointer is going to point to the end of the string. And then once we have the address for the end of the string, we can minus the address for the beginning of the string. The address for the beginning of the string is what's passed in. String is automatically going to be pointing to the first element in the array, or the first address of the array. So if we create a local pointer, and we'll just want to, again, create another constant char star, and we'll just say last address, how about? And this is going to be equal to the beginning address of string, and then we're going to increment it each time in our loop. So now we have last address. Again, this is a local variable that's going to store the address right before the null terminator. So now we can write our while loop. And our while loop is going to exit when we see the null terminator. Now we could do this two different ways. We could say, we could compare characters. So we could say something like while star last address, because we have to dereference it, is not equal to \0. Could do something like that, but that's kind of a lot of code. All we really need to do is just to say while star at last address, because if you dereference a null terminator, it's going to be equal to 0, and 0 is equal to false, right? We know that Booleans have 1 is true, 0 is false. So if it's false, it's going to jump out. So all you need to do is inside your while condition is put star last address. Again, this is going to dereference the pointer, and once it's pointing to the last address, it's going to be pointing to the null terminator. Now we have to make sure that we modify last address so that it eventually points to the null terminator. Here, all we can do is we can say plus plus last address. So each iteration of this while loop is going to increment the address until it sees a 0. A 0 represents the null terminator. So the end result of after this while loop is done executing, last address is going to be pointing to the address of the null terminator. We can then subtract the address of the null terminator from the address that was passed in, our string. And that's going to give us our length. So that's all we have to do on the next line. We can just say return our last address, and we actually want to minus the address, so we don't need to dereference anything or use the indirection operator. Last address minus string, right? So string is passed in. We don't modify it at all. That's pointing to the first character. That would be pointing to J. That would be the address, or for the first time we call in line 8, that would be the address of S. Last address is going to be pointing to the address of this last T. Actually, one more than that, the null terminator. If we say last address minus S, the address of S, it's going to give us the length. And that's what we're going to return. So I hope that makes sense. Again, on line 17, we're creating a local variable because we need to keep track of the last address, the address of the null terminator. After this while loop is done running, last address is going to point to after the T, the null terminator. Then we can just subtract the last address from the string. The string's address is pointing to S is when it comes in, and we don't modify that. So let's see what this, if this gives us back the correct length. When we run this, we should see the length for those strings we passed in. So we see 17, 0, and 5. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You got to count the space. 14, 15, 16, 17. That's right. We put in double quotes, which is empty, so that should be 0. And then Jason should be 5. So 17, 0, and 5. That's correct. So what we did here was we used pointer arithmetic to get the last address, plus plus, the incrementation operator, and then pointer arithmetic to get the length by minusing the last address minus the string. Pretty neat. I'm trying to demonstrate the power of pointer arithmetic, the notational convenience of it. How you can easily increment, decrement to get to various spots in a character array and get the characters out. In this case, we're just getting the addresses and then using the addresses to minus each other to get the length. So I hope this was helpful, and I hope make sure you understand everything I just mentioned. Again, the concept of a constant, the concept of plus plus, the concept of the condition. If you dereference an address and that's pointing to a null terminator, it's a 0, so it jumps out then. And then this concept of minusing two addresses. Thank you.